Steel drum rollers look impressive on a job site. The sheer weight, the size, it feels like serious compaction. But here's what nobody tells you. Those rigid steel drums are leaving microscopic gaps in your asphalt. Gaps that invite water, accelerate cracking, and turn a 20-year road into a 7-year repair bill. The fix has existed for decades, and most contractors still get it wrong. Today, we're going to break down the real science of pneumatic tire rollers, the kneading action, the thermal retention, the on-the-fly pressure calibration. And by the end of this video, you will never look at a paving operation the same way again. Let's start with the fundamental problem. When a steel drum roller passes over fresh asphalt, it applies uniform downward pressure across the entire surface. Sounds ideal, right? It's not. Here's what's actually happening beneath that drum. The larger aggregate particles, the stones, are being pushed into the mix with brute force. And because steel has zero flexibility, it cannot follow the micro contours between particles. The result is what engineers call a bridge-over effect. The drum essentially bridges over the gaps between stones, leaving air pockets trapped inside your pavement matrix. But it gets worse. On the surface layer, those same rigid drums can crush and fracture the aggregate rather than rearranging it. You're destroying the very material that gives asphalt its structural integrity. And fractured stone means one thing over time: water infiltration, freeze-thaw damage, and premature failure. The pavement looks fine when you leave the job site. The problem shows up 3 years later. Now here's where pneumatic rollers change everything. Think about kneading bread dough. When you press and roll dough, you're not just applying weight. You're manipulating the internal structure. You're moving material from one position to another, redistributing tension, eliminating air pockets from the inside out. Pneumatic tire rollers do exactly that to asphalt. As each rubber tire rolls over the hot mix, it slightly deforms around the surface contours. This creates a complex, multidirectional pressure pattern, what engineers call kneading action. Instead of just pushing aggregate straight down, the tires are gently shifting particles laterally, rotating them and fitting them together more tightly. And crucially, the air voids are being displaced from the bottom of the mat upward. You're not trapping them inside. You're systematically eliminating them, layer by layer, pass by pass. The result is a pavement matrix with significantly higher density and far lower void content than anything a steel drum can achieve. This is not a marginal difference. We're talking about void content potentially dropping from 8 to 10% with steel to under 3 to 4% with pneumatic compaction. That's the difference between pavement that lasts a decade and pavement that lasts a generation. Here's a fact that surprises most people. Temperature is not just a background condition in paving. It is the compaction window. Asphalt must be compacted within a specific temperature range. Too hot, it moves and deforms under load. Too cold, it becomes stiff and resists compaction entirely. You end up with high void content no matter how many passes you make. Steel drum rollers spray water on the drums to prevent asphalt from sticking. That water rapidly cools the surface layer, robbing you of your compaction window from the very first pass. Pneumatic rollers work differently. Rubber is a natural insulator. The tires retain heat from the asphalt surface themselves, and more importantly, they do not actively cool the mat. Engineers refer to this as the heat bloom effect. The mat stays at workable temperature longer, deeper, and more uniformly. For modern polymer-modified asphalt mixes, which are increasingly the standard on major infrastructure projects in 2026, thermal retention is non-negotiable. These high-performance binders require extended compaction temperatures to achieve design density specs. Pneumatic rollers are the only equipment that consistently delivers. Now let's talk about the technology that makes modern pneumatic compaction truly exceptional. Air on the run systems. Traditional pneumatic rollers required operators to stop the machine to adjust tire pressure manually, a real limitation on a live job site. But modern machines, and this is a genuine game changer, allow operators to adjust the PSI in every tire while the machine is moving, in real time, via a centralized control panel in the cab. Why does this matter? Because optimal compaction is not a single fixed pressure. It's a dynamic strategy across multiple passes. Here's how it works in practice. On your initial passes, you run low tire pressure, somewhere between 60 and 80 psi. Lower pressure means a larger tire contact patch, which means gentler, more distributed force. And this stabilizes the loose mat without shoving aggregate out of position or causing shoving and rutting on a mix that's still very hot. Then, as the mat temperature decreases and the mix stiffens slightly, you progressively increase tire pressure, up to 100, 120, even 130 psi on the final passes. Higher pressure concentrates force, drives aggregate deeper into the matrix, and delivers the maximum density finish that your project specifications demand. Compare that to a steel drum: one weight, one force, zero adaptability. It applies the same pressure on the first pass as the last. On a complex modern mix, that's not a compaction strategy, it's a gamble. So what does all of this actually deliver at the end of a project? Let's talk outcomes. First, moisture resistance. The pneumatically sealed surface, dense, low void, impermeable, prevents water from penetrating into the asphalt matrix. Water is the number one enemy of pavement. It weakens the binder-aggregate bond. In winter, it freezes, expands, and creates potholes from the inside out. Eliminate water infiltration, and you eliminate the most common cause of early pavement failure. Second, oxidation resistance. Lower void content means less oxygen exposure to the asphalt binder. Oxidation causes the binder to harden and become brittle over time. That's what makes old roads crack and ravel. A pneumatic finish dramatically slows this aging process. Third, and this is what contractors and DOTs are paying attention to in 2026, macro texture performance. Look at the visual difference on screen. A standard finish looks sealed, but under certain lighting or after light rain, you can see the surface variation. A pneumatically finished surface has tighter, more consistent macro texture, better skid resistance, better hydroplaning resistance, quieter ride. The bottom line, pneumatic compaction is not a premium add-on. In 2026, it is the baseline standard for any infrastructure project that expects to outlast its design life. It is the final defense and the most important weapon against premature structural failure. If you work in paving, civil engineering, or infrastructure, you just saw exactly why your specifications should be calling for pneumatic compaction on every final lift. If this changed how you think about roller selection, hit like. It genuinely helps this channel reach more people in the industry. Subscribe for more deep dives into paving science and equipment, and drop your question in the comments. Are you running pneumatic rollers on your current projects, or are you still relying on steel? I read every comment.